Hello guys, welcome to the Stereochemistry class. First, we are going to see what is the definition of stereochemistry. It is the branch of the chemistry which deals with the three-dimensional structure of the molecules and their effect on physical and chemical properties. It's known as stereochemistry. Before we get into the stereochemistry class, first we have to know the concept of isomerism and their classification. What do you mean by an isomer? Isomers are the compounds that are having the same molecular formula but differ in their structural arrangements or sometimes spatial arrangements are known as isomers. As you are seeing in the two charts, in the first chart we have classified the isomers into constitutional isomers and stereoisomers. The constitutional isomer is further divided into 6 types. First one is the chain isomerism, second one is the position isomerism, third one is functional isomerism, and fourth one is metamerism, and the tautomerism, and the ring chain isomerism. What do you mean by this chain isomerism? This chain isomerism, the compounds having the same molecular formula but leads to the different compounds. For example, we are going to see the compound pentane. So this is pentane. One more compound is possible is this is isopentane. This is neopentane. The carbon connectivity is different in each compound, leads to the different compounds. That is called as chain isomerism. Basically, in the constitutional isomerism, the isomers differ from their carbon connectivity, but not in the stereoisomers. Okay. Next one is the position isomerism. The position isomerism is compounds having the same molecular formula but differ in their position of the functional group or any special elements. For example, in pentanol, the compound, this is pentane 1-ol. Similarly, this compound is pentane 2-ol. One more compound is possible with this compound. This is pentane 3-ol. These three are position isomers, differ in their position of the functional groups. And next one is the functional isomerism. The example for the functional isomerism is this is a compound of diethyl ether, and one more possible compound is ethanol. In these two compounds, the molecular formula is same, C2H6O. The one of the possible compound is diethyl ether, and one more compound is ethanol. Leads to the different functional groups. Next one is the metamers. So what do you mean by a metamer? So metamer is nothing but the compounds having the same molecular formula, same functional formula, but the arrangement of the alkyl groups on either side of the functional group is different. The example is diethyl ether, one more compound is methyl propyl ether. So this is an example for metamerism. Same molecular formula, same functional group. On either side of the functional group, the two alkyl groups are different. This is called as metamer. Next one is the tautomerism. Tautomerism, we are going to exist in dynamic equilibrium. For example, if you know the compound of ether acetoacetate, this is the compound ethyl acetoacetate. It is going to exist in one more state. Here, the same compound ethyl acetoacetate, it is going to exist in keto form and as well as in the enol form. In the enol form, the compound we are going to name it as enol because of the two functional group. One is the alcohol and another one is the double bond. That's why we are going to call it as enol. In the keto form, it is going to exist in the ketone functional group. And these two isomers, they are exist in equilibrium, means interchangeable compounds. Okay. So in the equilibrium state, it is going to exist in between the two compounds. This is called as a tautomerism, and the last one is the ring chain isomerism. So ring chain isomerism we are going to observe in the compounds like cyclohexane. The molecular formula of the cyclohexane is C6H12. One more compound possible for this molecular formula is cyclohexene. Here also the molecular formula is same. Here, with the molecular formula C6H12, one of the possible compound is cyclohexane. One more compound possible is cyclohexene, or particularly we are going to call it as 1-hexene. So this is the example for the ring chain isomerism. Okay, in the next class we are going to discuss with the stereoisomers and what is the difference between the constitutional isomers and stereoisomers, and we will study further